All right. So, hello everyone. Welcome to Intro to Backend lecture. Today we're going to be talking about deployment. So, some announcements besides the one I just said. PA5 is due on Wednesday. This is a very light assignment. It's just containerizing your, uh, I think PA4 code, and then just sending in that kind of information. So there's no actual like big programming part of it. So you guys should be able to try not to use a slip days for it because it's not too heavy and it'd probably be better used elsewhere. And PA3 grades are coming soon as well. So some quick review on what happened last week. Um, we talked about containerization and the process of having your code um, be built into a Docker image, and that image can be run as a container, which acts as a process that has like a virtual uh, operating system that runs your code, and the image is meant to be like the minimal state that your code needs to actually run. So it's a nice light way of running your code in any sort of environment. And so you can build a code in images, run the images into containers, and you can push them on Docker Hub, kind of like GitHub for these Docker images, so that other people can pull your image. So moving on to new content and some kind of old content, we're going to talk about servers. So like we talked about around lecture one, servers are, they can be a software or a hardware device, and these accept and respond to clients that request them. So they serve information back to the clients who request them. That's why they're called servers. And these requests are made over a network. And typically that network is the internet. So some examples of web servers, since there can be many types of them. The most common one that you guys probably know most about are web servers. These host websites, show like their web pages, and can have their apps ran through web browsers. So web browsers request information from the servers, web servers, and the web servers return like the website. So the web browser would be like the client in this case. Some other web server types are email servers. These email servers manage sending and receiving emails. So the clients would actually be like, what's an example? Like the Apple messaging app or Apple Mail app or Gmail. And those would request like the IMTP server that stores your emails, requests them, and so on. And one other server that's probably less well known is an identity server. These manage like login and security roles. So if you guys know about when you like try to log into Student Center or some other Cornell thing, you typically go to like Cornell's web page for logging in. That's like shibboleth in the URL. That's Cornell's identity server for actually logging you in and making sure that you're authenticated with your net ID and such. And that's an example of that. Any questions about like these three kinds of servers? In this class, we're going to be mainly working on, well, entirely working with web servers. So the way a server works like on the internet is that it's assigned a unique IP address. This IP address distinguishes it from other servers and allows a client to connect to them on the internet. And they connect to it with like a router. So an example IP address is here 127.0.0.1. That's the local host. Every computer has that. And IP addresses can come in like this format, which is IP version 4, or it can come in a much larger format called IP version 6, which was made to like make the space of the possible IP addresses much larger, since we're actually kind of running out of unique ones at this point into in the IP version 4 space. But that's just a little trivia about that. And so if you guys want to like connect to Google, have you guys actually ever tried finding like their IP address and typing it into the URL? I guess it's like a lot less common to even try to find websites based on their IP addresses. And most likely you will use like their website name or their domain name. So like google.com. So if you type this into your browser, you can connect to the server via their domain name. And the DNS servers, which are like around the world, have like DNS translation tables or like That might not be the exact name, but they translate those domain names to IP addresses so that your router can actually figure out what Google means and where it's actually located. So here's a nice diagram. Imagine you're like the computer on the top left, you're the client, and you want to find google.com. You type that into your browser, you send it. That request is routed to a DNS server somewhere in the world. And it actually looks up in its inner table that google.com is linked or mapped to that IP address. It's actually a lot more complicated than it looks here. It's kind of like a tiered system where you have like more local DNSs than higher like width ones. It's a lot more complicated than this here, but once you get the IP address, your computer or your browser can actually then directly connect to Google's servers. And then you can go to wherever website you want it to go. In this case, it'll be google.com. So now we're going to talk more about deployment and how you can do that with your own apps. So if you have a web app that you want people to use, you have a few certain important needs. The first need is that your app is always running so that people who want to use your products or service can always use it whenever they want and not when your laptop is turned on. It also has to be open to receiving requests online. So it has to be accessible to the internet. Oh, I actually said the third one as well. So yeah, it has to be accessible publicly through the internet. And also the hardware that is managing it and like connects it to the cloud is like, wait, sorry, let me repeat that. So it has to be also on hardware that's like easily manageable and connected to the cloud so that you as like the server admin can access it anywhere in the world just by going to it online. And so the way to do that is by renting a server through some server service company. So you can now run your application on a server from the cloud, and that server is probably in some server farm somewhere in the country or somewhere in the world. And when you have your server, you want to actually run your code in a container like we were talking about last week. So you would have your code in a little container running on your server. And this renting service will allow you to actually manage your server online. And they will handle like the physical maintenance of the physical server while also giving you tools to like for security of the server. They also give you tools for scaling and how to deal with crashes and so on. And so here are some pretty big services that allow you to rent servers. The top one is Amazon Web Services. This one's very popular. The bottom one is Microsoft Azure, which is also pretty popular. The one on the left is DigitalOcean, which AppDev uses for their apps. And the one on the right is Google Cloud, which we'll be using in the course and which you guys have free credit for this year to use for PA5 and the Hack Challenge. You have a question?
For example, let's say if we have an independent project and we are like choosing one.
I don't really know like the real difference. They all have a similar, like they all work pretty similarly. Some might have different like services they offer. Like I know AWS and Azure have like chat GPT integrations and stuff. They're all have a similar base. They might have some different amenities and stuff, but you can't go wrong with any of them. I guess the main determining factor would be like the price, because it does cost money to have servers and other services. And so I know some of them have like student plans. And I think I got one from Microsoft Azure for like a month-long student free plan. So you can look at that if you guys want to do your own projects as well. So let's say you have your server, you made a virtual machine on Google Cloud, but how do you actually access it and how do you use it on your computer? So the way you actually connect to your virtual machine on like Google Cloud is through a protocol called Secure Shell, which is also said like SSH. And that's a network protocol that gives you access to a server from a specific port. I think the port's 22. And it allows you to connect to your server and then like open and view its resources. You can execute commands on it like a terminal. You can also install packages, update software, And most importantly, you can run your code on the terminal, on the server. So here's what it looks like. I think someone here is like trying to go into the eatery server on DigitalOcean. So what they do on top, if you can see that, is they write SSH, which is the command to connect via SSH. They put -i, and then they include something called a PEM file, which is called server.pem, which has their private key to actually authenticate into the server. And then the last part is if you see app dev, that says that's the user of the person authenticating. And then after the @ is the server hosting domain of the place they're trying to enter. So eaterybackend.cornelappdev.com. That's where the server is held. And once you do that, you actually turn your terminal into the server's terminal. So if you like see on the bottom, the user is currently working in the eatery server on DigitalOcean. So the way this is actually even safe at all is like through the SSH process. You have to provide a username and a password. And the way this works is the password is like a secret private key. And while the public key is, I think, what do you say? Public key is accessible to anyone. People with the private key can actually create the passphrase to enter the server. And the private key is stored in that PEM file, server.pem, and you have to keep it secret or else other people can enter your server with your username. And so this is like an encrypted string. It's much stronger than secure passwords. I mean, much stronger and more secure than log passwords. And you learn a lot of the specifics from like CS 2800 with RSA encryption. So that's where most of the real like theory part comes from. So like we showed earlier, all you need to say is SSH, then the user at, and then the server domain name, URL, I mean. And you can include the PEM file with the -i and the file name. If you don't include that into the command, you'll be prompted with actually putting the server key itself. And if you're trying to connect to a server you've never connected before, it'll ask you to add it to known hosts. It'll do it automatically. But after you add it to known hosts, it'll authenticate your private key and the public key. And then if you're successful, you'll end up in the virtual machines terminal. And then you can do really cool stuff with it. So for example, you guys are going to be integrating Docker with your Google Cloud virtual machines. So like we said before, Google Cloud is a cloud service that gives you the availability to make virtual machines and have them accessible online. And if you have a Docker image on Docker Hub, you can pull that image onto your virtual machine and then run that container. Well, you can run the image. And then from there, you'll have a container running on your VM. So you can build, push, release images to the web, pull them on your server. You can install Docker on it as well, so that you're able to do this, or do that first. But yeah, that's just kind of how it works. You run your container on your server. Is there any questions about the process of this or anything else? Not, we're gonna keep going. So you have your web app, it's accessible online. You can go to your IP address, or if you bought a domain name, you can type in the domain name and then access your cool backend app on your web browser. But imagine if it like gets very popular and need to optimize it somehow. So we're gonna go through some ways to do that, but it's not gonna be anything that you guys will have to do for this course. It's just kind of cool things to learn about. So the first thing you can do is called clustering. So it's like having a group of multiple virtual machines connected to behave as one system. And each server is going to be optimized for one purpose. And this will end up typically creating a better performing system. So I think here's a diagram. So here's what you guys will probably have to do in your PA5 or final projects. You'll have your server and it's hosting, say, a web application. You probably always won't be making a web application, but you can have a web application. You can have storage of files. It also could be hosting your database on that server. And one issue with this is that if your server were to crash, then your whole what do you call it? Your whole stack crashes with it. So then no one can actually access anything that you guys have on your server. So imagine if you had multiple servers dealing with multiple tasks. Like you had one server that dealt mainly with your website, one that dealt mainly with your file storage, and one that's like for your database. If the server storing the files crashed, you guys would technically still have your website running and your database running. I think a better example is like with Facebook. They have many products like Facebook itself, Messenger, Instagram. And if Instagram goes down, Facebook and Messenger still are up, right? Because they're on different servers, even though they're under the same company. So the benefits of having this kind of system are, first of all, having backups in case they're like more redundant. If one server goes down, you can probably use the other one as a backup, and crash handling since there'll be backup servers running other what do you call it? Other features. So this will result in more data resiliency and application resiliency in those ways. It also kind of helps you manage your system better, having discrete servers doing their own thing. And also scalability and load balancing comes with this, as we'll talk about right now. So imagine you had your multiple servers running multiple web apps and such, and you had a separate load balancer server. So when you get web traffic, you might not want to have it all go into the same server. The load balancer will actually help move that traffic equally into multiple servers so that the load is balanced and one server isn't overloaded. So as you can see like that. So if you have a lot more web traffic, you probably have to like get more servers and they'll be balanced between them all. So yeah, having multiple servers is always pretty much a good thing. It's also a lot more expensive. You have to pay for each of them. So yeah, and now we're gonna go through our demo. So any other questions real quick before you go through that? Yeah. They can be. So if they are the same, then you can manage them multiple, like have less traffic for each of them versus having all of them on one. There's also, you can have like region-based ones. If you're like playing an online game, you have like North America region, Europe region, instead of having them all go into the same server. It just kind of helps balance out the people using your app and balance out your backend. So is that good? All right. Yeah.
I have a question about like concurrency, if you have like a database that has to be shared, right?
Mhm.
Like, how does it just automatically handle that for you, or is there like the instance of the database on your server, or you store it separately and you have a connected to it?
If you take databases, there's a lot of stuff about concurrency. They have a lot of things about how the database management system will handle concurrent transactions. Even though I'm a database T, I can't really remember off the top of my head, but it's a whole course about it. But you can have one database, you can have multiple. I think it depends on like the size of your project, but the database should have its own concurrency handling in it. If it's Postgres, I know that for sure. Any other questions? If not, we're gonna go right into our demo.
Yeah. Oh, let's see. Can you hear me? All right, we're good. So today we're going to be creating a virtual machine in Google Cloud. So again, going back to this ed post, please use the student coupon retrieval link. That's how you receive your free Google Cloud credit. And you're going to need this for PA6. You're going to need this to follow along in the demo today, but this is just going to be on YouTube. So it's fine if you just kind of just look at what I'm doing and then kind of replicate it later on. Yeah, so first we're going to go to Google Cloud. There's a link on the backend textbook course, the demo area. And so Move this out of the way. Uh-oh, that's not good. See, yeah, okay. Yeah, I can't type it on here. Let me see.
Wait, just the X button. Try going in. If this one's your video,
Okay,
we've already used it.
yeah.
We just try to log in.
I had this issue before, so I'm just gonna take a few minutes trying to log in. Oh, okay. All right. So I'm in now. For you guys, it should be pretty simple. You should just be able to log in. If you have trouble logging in, the way I did it was you're gonna get some sort of email in your Gmail. And then once you like kind of redeem the coupon, you can just click the Google Cloud thing in the top left, and that should get you into Google Cloud. So now we're just gonna go to the dashboard. And so these are the past projects that I did for, I guess, Demo 6 when I took the course last year, and also PA 6. So today we're just going to be creating a simple VM. So first thing we're going to want to do is create a project. And so we're just going to name this Demo 6 Network. And then we're just going to leave the organization and location as cornell.edu. So we're going to create this. And sometimes Google Cloud, it takes a little bit of time for it to actually like create some stuff. Oh God. Let's go back to. So after we've created the project, we need to create a VPC network. So we're going to go over here, click VPC networks. And so if this data cannot be loaded, you have to, I guess, enable this thing called enable computer or compute engine API. So once we enable this, we should be able to create our VPC network. So yeah. Enable it. Yeah. Okay, so now that it's enabled, we can now go to create VPC network up here. And so for the name, we're just gonna again do demo 6 network. We're not gonna have a description. So we're gonna want to disable this. So for the subnet creation mode, we're gonna have this as automatic. And then we're gonna have this IP stack over here. We're just, let me see. Should be full. Firewall rules. We're going to allow SSH. And then we're going to want to have this as regional. Remember, do I have to search the on the
Just the
Hmm?
TCP IP in the bottom.
Where is it?
This is new.
All right, I think that should be it. I don't think we need to enable this.
Ingress.
Hmm?
If you want to ingress or to connect to your server via not denied, but it's like a trade. With the API.
Yeah. See. Yeah, I think that should be it. There's no way I can. Yeah. Okay. So I think that should be it for creating the VPC network. So yeah. So once we've created this, we're gonna go back to the navigation menu, go to compute engine and go to VM instances. And so we're gonna create a VM instance for this project. And then remember, a virtual machine kind of allows you to run your app separate from everything else that's on your computer. So now that we're creating this, we're going to name this demo 6 virtual VM. Okay, so for the region, we're just going to want to set this to like whatever's closest to us. So we're just going to say Northern Virginia. And then machine configuration should be fine. The next thing we need is memory type. Okay, that's strange. Okay, yeah. So this is like a machine type over here. So we can use so there's different like sizes of memory that you can allocate to your virtual machine. So if you click like medium, at some point it should tell you like the cost of this. So yeah, there's a $28 monthly cost for this. And then if we, where is it? If we go back and change it to like small, the cost should theoretically decrease because you're kind of paying for the memory. So yeah, it goes to 1487. So for this, we're just going to use small. You could use micro theoretically, but we're just going to use small. And then the next thing we're going to want to change is this boot disk thing because the default is set to Debian, and we're going to want to change this to Ubuntu. And Ubuntu is very common in the industry. It's very easy to set up on Windows, and it's also used in app dev. So we're just going to change it to Ubuntu, and just select that. And so for the firewall, we're going to want to allow HTTP traffic. In general, HTTP is not as secure as HTTPS, but HTTPS requires a little bit more setup that we're not going to go over in this course. So we're just going to leave this as allow HTTP traffic. And then that should be it. Oh, no. So the last thing we do is we go to advanced options, and then we're going to click on networking. And so when you go to network interfaces, and so if this doesn't automatically like show demo 6, you just kind of like select the network that you're using. So here it automatically showed demo 6. So we're good. We do IPv4. That looks good. Yeah. So then I think that's it for, I guess, creating the VM. So we just create it, or Sub-network. Okay, for it's saying that I need a sub network, even though like there's no sub network. Like the only thing I've created is this, right? So then like, it doesn't let me create it because I have to specify something. It just defaults to like this. Uh, Northern Virginia, yeah. Okay, so then what's that? Wait, what? Oh wait, yeah, it's this. Okay. Oh, okay. Okay. So then, yeah, we have the network and the sub network. We do all this. Yeah. So then if we create this, we should be able to create our VM instance. And so, it's going to take a little bit, but I guess it's going to set up over here. And yeah. So I think that's it really for the demo. It's a pretty short one. It's just kind of creating a VM instance. And then in the next, I guess in Wednesday's demo, we're gonna actually use this VM instance to like SSH into our server. So yeah. All right. Yeah.